Alrighty. Looks like we have a hard one today. Maybe it should have been yesterday. Okay, count the number of ideal arrays. You're given two integers n and max value, which are used to describe an ideal array. And a zero-indexed integer array of length n is considered ideal if the following conditions hold. If the array at I is a value from I to the max value, so is a value from I to max value for every index from 0 up to n, and if the array of I is divisible by array of I minus 1. So array of I is a value from 1 to max value. Interesting. And then basically the value at array I is divisible by the one before it in the array. Return a number of distinct ideal arrays of length n. Interesting. Since your answer may be very large, return modulo 10 to the 9th plus 7. Okay, so if n is 2, so the length of the array is 2, and the max value in the array is 1, or 5, so it's values between 1 and 5, and every value has a value before it that's visible by it. So divisible that divides it. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Okay, 1 obviously works for the starting value. 2, 2, 2, 4, 3, 3, 3, 4, 4, 5, 5. So there's 10. And then if the array is of length 5 and the max value is 3, I think it should be like 1s and then like 1, 1, 2, or 1, 1, 1, 1, 2. Interesting. So you can always have like the same number repeated, right? Because it's always going to be divisible by itself. And you can always have it can always increase but never decrease. Okay. Seems reasonable. Seems actually maybe pretty easy in some ways. Because for any given number, you only have a certain set of following numbers that would work. I guess there's for any, so you can go with like 1, so let's say the max number is 6. You can go like 1, 2, 6, or you can go 1, 3, 6. You can't go 1, 2, 3, 6. So for any given number, you can identify how many following numbers there are that are still below the max value. Does that work? Does that quickly solve it though? Okay, let's just go ahead and try something here. So let's go ahead and do some simple type problems to identify what the pattern might be. So if you know that your max value is, let's say n is 2, max is 5. So it can go 1, 1. So it can start with anything between 1 and 5. So 1, 2, 3, 4, 5. And if you go starting at, I wonder, because really you can always start with 1, right? You can always start with 1, so therefore if you were to make a chain that starts with 1 and just figure out what the possibilities are from that chain, you'll eventually have something with 5. So if you do 1 goes to 2, or 1 obviously goes to 1, but 1 goes to 2, 1 goes to 3, 1 goes to 4, 1 goes to 5. And then from there, go 2 goes to 2, 2 goes to 4, 3 goes to 3, 4 goes to 4, 5 goes to 5. So what does that mean? So for each number from 1 to the max value, you can determine how many following numbers there are. For each number, you can determine how many following numbers there are. And that should be fairly quick, right? Like n is, n was kind of big. 10 to the 4th. You can kind of determine, 10 to the 4th is not that big, it's like 10,000. Okay, let's try this. So, do I need to make a graph here? It's kind of like a graph. Okay, let's say follows, and this is going to be, for every number, I'm going to have it's going to be default dictionary or a 2D array, or array of list. A list for every value from 4k in range of 1 to n plus 1, maybe. So let's say that I go for every value in range 1 to, or this is the max value, n is the length of the array. For 1 to max value plus 1, I'm going to say that, can I quickly actually identify it? It's kind of long if I do every multiple of the number. It would be kind of long if you did every multiple. So something like follows, you kind of want it to. Follows, like, if you can say that 1 goes to 2 and 1 goes to 3, and 1 goes to 4, well, if you can say that 2 goes to 4, that implies that 1 can go to 4 as well. Because 1 goes to 2. Or you can say how many numbers follows it. But you kind of need to know the actual thing. Fuck. Alright, let's go through example 2 here. N is 5, the max value is 3. So you have all 1s. You have all 1s followed by a 2. And the 2 can be any of the later spots after the 1. So there's 4 possible ways there. And then you can have all 1s followed by 3. That's also 4 possible ways. And then you can have a 2 as the start. and then you can only do 2 followed by itself. And then lastly, you can have a 3. What to do? So it's all the numbers for each number. I wonder if we can just do this using recursion. Maybe I'm overthinking this. Now the recursion is, well, you can't use recursion using functions. You have to do like an iterative loop recursion because the call stack would be too long if you chained it to 10 to the 4th calls. But if you can simplify this, because if n is 1, right? If n is 1, then the number of ways that you would do that would simply be the number of ways that you have 1 to the max value. So the max value is your number of ways of doing n equals 1. And then if you do n equals 2, n equals 2 would be going backwards from that. Because if you have max value is 5, then your array, and n is 1, then your array is just 1, 2, 3, 4, 5. So if you have n equals 2, then you go backwards 1. And how many ways can you put a number before the 1, 2, 3, 4, 5? So for 5, there's only 1 way. Oh no, for 5 there's 2 ways, 1 and 5. For 4 there's 3 ways, 1, 2, and 4. For 3 there's 2 ways. For 2 there's 2 ways, and for 1 there's 1 way. So maybe so for each n value, you go through all the prior possibilities to it. That would probably be n squared, kind of, but okay. And then I have to do this using a for loop rather than recursion. So let's say I have my answer, and let's say I keep track of the number of ways that to have last value, or I guess maybe it wouldn't be considered last, it would be start value of smaller sized array. Less than or from less than n. So if we start by saying that for every one-sized array, the last value being like 1 through max value, there'd be 1 way of getting there, right? I'll keep track of it using counts. That's 1 times the max value plus 1. Let's say max value plus 1, so index 0 should be like 0, because you can't end with 0, but you can end with 1 through max value. And then you can say that for so we want to go downwards, basically. So if the max value is like 1 through 5, then you can combine it with, we'll see, for every value in the range of 1 to max value, max value equals 1. You're going to, okay, so what am I thinking about here? So my last value is like that, or my only value in my array is like that. And the counts that these things, so this is value, and this is the counts. So this would be 1, 1, 1. So if I think about 5, there's 2 prior values to 5 that I can do, because there's 2 numbers that are divisible by 5. So would I change it? Would I do 1 times 2? The number of ways that you end with 5 times the number of ways that you can have a number prior to it. And then this is like 1 times 3, and this is 1 times 2, and this is 1 times 2, and this is 1 times 1. So that ends up being 2, 4, 8, 10. Okay, so that kind of works. Let's say I wanted to say have n equals 3. What does that mean? How would I count that? Well, there's still 2 ways to get 5. So it'd be another, there's 2 ways to get 5, but that's not correct. But currently there's only one ending, there's only one, the 2 ways to get 5 here are like 1, 5 and 5, 5. So currently there should, on the next go, there should only be a count of 1, 5 to work with that I'm multiplying by 2 by. And this is like 1, 4, this is 2, 4, this is 4, 4. And this is 1, 3, 3, 3. This is 1, 2, 2, 2, 1, 1. So the next iteration, I should start with saying that there's only one method where 5 is the last number. So like here on the next iteration, the ending value, or not technically the starting value of that 2-sized array, there's, for 5, there's actually, just 1, 5 as the start value. For 4, there's 1, 4. For 3, there's 1, 3. For 2, there's the 2, 4, and the 2, 2. So there's 2. For 1, there's the remaining 5. And then you multiply this by 1, you multiply this by 2, you multiply this by 2, you multiply this by 3. Multiply that by 2. So let's say this equals 2, this equals 3, this equals 2, this equals 4, this equals 5. So this is a total of 16. So double checking the thing here. So let's say I had n is 3. Alright, 16. So the multiplier is the same each time, because every time you start with 5, yeah, so the multiplier is the same. You just have to update the counts, or you have to update the number of ways you have an array that starts with that value. Okay. So for 5, for each way you have 5 here. For each way that you have 5 here, then what? Each way you have 5. There's only one way that repeats, and there's one way that has. So for each divisor that has, so if 5 has 5 as divisors, then you would increment the count of the ways that would be the start. That divisor is the start of the next iteration. Isn't that the same each time though? It is the same each time, right? So there's something that I'm missing here. 5 can go to 1, 5. 4 can go to... Okay. Alright, let's do one more here. So this is n equals 4. So 1, 2, 3, 4, 5. So here the counts, you'd start by saying that there are, well, there's still 1, 5 here. And for the 4s, there still should only be one way of getting a 4. For the 3, there's still one way. Wait, I'm multiplying the wrong numbers. No, I'm sorry. For the 2s, there's how many ways? There's 3, 4, there's 1 from the 4, 1 from the 2. So I think this is still 2. This is still 2. And for the 1, this one is the remaining amount, I think. So like 1, 1, 1, 2, 3, 4, 5, 16. So I think this is like 11. 11 times 1. So for each number of ways getting 5, here's 1, 1, 1. For each way of getting 4, each 4 here produces 3 things. So each 4 here produces 3 things. Each 2 here produces 2 things. But there's 2 2s here. So that should actually produce 2. Each 2, that causes it to be another 2 in the next iteration. Another 2, and another 2 2s from the 2s, and 1 2 from the 4. And here the remaining things is 1, 2, 3, 4, 5. I think this might be 10. So there's 5 here. Each of those ways can produce a 5 or produce a 1 in the next one. Yeah. So there's 10 here though. So each one of those ways should be able to produce a 10 here or produce a 1 here. And then there's 2 2s, so each of these 2s can produce another 2 in the next iteration, and one of the 4s can produce a 2. Yeah, okay. So I think this is the correct calculation. So it should be 23. Agree. So for every count of the previous iteration, you make a bucket for the next iteration. You multiply it by a set amount each time, and then you iterate through it. This seems very, very slow. Like this is n squared, maybe n to the 4th, maybe? N squared times the longest bucket chain. But it's a start, I think. Okay. So for each number from 1 to max value, I make a list of divisors. And then for each, okay. Let's say I have a list of divisors. And this is going to be a list for every k in range 1 to for k in range 1 to max value plus 1. Alright, let's put get list of divisors for n Python. Sorted. Okay, let's go ahead and add that here. Divisors. Okay. So it's gonna be a list. I'll just call this let's call this divs to not confuse it. For 1 to square n plus 1. This is confusing. Say num. Okay, so you have a empty array at the start. It goes through 1 through the square root of the number, which is going to be the maximum divisor. Okay, that's pretty straightforward. Doesn't seem very fast. Okay, if I if I doesn't equal, if it's not divisible, if I not equal to n divided by I not equal to n divided by I. What does that do? If if 1 isn't equal to, oh, if it is divisible, then append it. If it's not divisible, then append, oh, I see. If it, that should be something where, yeah, so if it's divisible, then you should be appending both I and the other dividing value. Okay, so it's not the square root, basically. Right, this is divisor, append other factor, other divisible factor. Okay, I'm pretty sure that's what this is doing. And then sort the divisor. I'm not sure if you need to sort it, but whatever. Okay, so for the list, so the divisors would be, I guess it'd just be get divisors of k. Hey. So get divisor of k. Okay, let's go ahead and just print that out to make sure this works. Okay, so 1 is divisible by 1, 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, 2, 4, 5 is divisible by 1, 5. Okay, so that's fine. I probably don't want 1 divisible by 1. So maybe I can say that this is how do I get rid of the I can say start with range 2. No, that's right. I don't want to do an if statement, do I? Maybe I can do range from I. You do want to start with 1. I mean, you can always append 1, maybe. Maybe you can start saying the divisors always has 1. And just start when you have range 2 and onwards. And then divs here. I think maybe this might be fine. Oh, it is definitely not fine. Okay. Teaches me to mess with the code that's generated by ChatGPT. So this should be 1. Alright, fine. Divs at 1. Actually, is the index is actually get divisors of 0. So I think the index thing is still 0 dot pop, maybe? Yeah. Okay, what did I do here? Oh, let me actually print out the divs. Okay, 1's divisible by 1, 2 is divisible by 1, 2. This is too many. Four is divisible by 1, 2, and 4. Why is it? Did it have this before? Before I made this change? Huh. So 4 is divisible by 1, 2, and 4. Wait, that's not even correct for 5. 5 is only divisible by 1 and 5. What did I do here? Divisors, 1 goes to square root. Append the divisors. I mean, all I changed was this, right? K goes from... Huh. 1, 2, 3. The divisors of 4. The divisors of 5 is just wrong. Oh, I tabbed it wrong. Ah, jeez. Good lord. That still didn't work. If the square root divisor, append the other divisible factor. If I doesn't equal the square root, this dividing by n of I. But why does it do this then? 1, 2, 2, 4. This 4 is by 2, and then 2 is also 4 divided by 2. Okay, fine. Let's go ahead and print the number. Four is by 2, so when I is 2, nums divided by 2, nums mod 2 is 0, appends 2, and then if 2 doesn't equal 4 divided by 2, which it shouldn't, then it appends another 2. Alright, let's do this here. Array equals get divisors of 4. Alright, so let's go ahead and dive deeper here. Print I num mod I num divided by I. Okay, so 4 mod 1 is, so I is 1, 4 mod 1 is 0, and 4 divided by 1 is 4. That's correct. And then I is 2, 4 mod 2 is 0, 4 divided by 2 is 2. So 1 still append the 2. let's go ahead and just print out also my divisors after each iteration. So after the first time it's 1 and 4, and then after the second time it's 1, 4, 2, 2. Why does this trigger? Two and 1. What? Oh, wait, this is num. Oh yeah, this should be num. I see. I screwed up on the changing the variable names. Stupid. Okay. Should be fine. Okay, so yeah, I screwed up in the variable name, which is why there was the duplicate ones even. Okay, so so your divisors are those. And I think that should be, I'm not sure how fast that is, but we'll hope that it's fast enough. So for every, so now it's, so you have accounts. I think you need to have a current array. And it's probably going to be, it might be reset for each time. So for every iteration, let's say loop in range, size in range from 0 to max size in my array. My counts originally should be 1 for everything. Yeah, my counts is originally 1 for everything. I'm gonna say maybe I have a next count. It's actually, say next count is going to be an array starting with 0 times max value plus 1, and going through every ending. So for every start val in counts, for every start value in the range of 1 to max value plus 1, I'll say the count of that start value is counts at the start value. So for instance, there's 1, 1, and then that means that I would in the next counting of it, for every divisor in the divisors of this start value, maybe start value minus 1. So if it's 1, then there's 1. If it's 1, then it's just 1. If it's 2, then it's 1, 2. I'll go through and say that the next count of this start val is going to be incremented by the number of ways that this count has occurred. And then the number of ways that this count has occurred. Yeah. And I do that for every one, and then maybe afterwards I'll go through for every value in range of max value. It's going to be the count the counts of this thing, the counts of this value is equal to the next count of this value times the number of divisors it has. Yeah, I think it's the number of divisors. Length of divisors of this count of this value. And then once you have it finalized, then you go through all your well, your answer is going to be just the sum of your counts. You need to use modulo here somehow. Mod. Answer. Okay, so initially all your counts is 1, and if n is bigger than that, then if n is bigger than that, then you want to do, if n is 1, then you don't want to do it at all. So I think this should be 1 through n. So if n is 2, then you actually do an iteration. If n is 1, you don't want to do any iteration of this. Okay, so if you have your initial counts, which is all 1s, and then you want to find how many times there's a starting value, how many times you start with each starting value. In your next count. So you initially say it's 0. And then for each value, you say that the next, get the count of that value, sure. So it's like 1 for the first iteration. And then for each divisor of it, for each divisors of this start value minus 1. Okay, sure, for each start divisor, you say that the next time you, if you treat this as how many ways you can have it start, the next one is based on how many ways you have it currently. Have this count. So 5, if the start value is 5, the start value is 5, the count is 5 is 1, and then for each divisor of 5, like 1 and 5, you increment the next count of 1 as by 1, and increment the next count of 5 by 1. And then for every value in the range, then after you figure out these starting counts, you multiply it by the number of divisors to get to what you want. Alright, I think this is reasonable. Next count times length of divisors of the value. List index out of range. Counts of value equals next count. Values out of range of divs. Oh yeah, okay, divs I think uses value -1. Kind of confusing. Alright, too big, too big. Alright, so let's go ahead and see what's going on here. So for size 1 to n, let's say I print out what is in my counts at the end of each of these iterations. One, 4, 4, 9, 4. That seems a bit excessive. So, and it does it once, which is correct. 1, 4, 4. The 9 is really large. Okay, so next count starts at all zeros, and start value is from 1 to 5. The count of 1. Oh, I see. Yeah, okay. So I'm modifying counts in the process of doing this, and that's using it in the, I'm using it again. I think I need to reset it somehow, like do a clear counts. So I need to separate how I define these. Counts would be okay, I'm going to call this next base. Yeah, the next base. And I'll have a next counts as something separate from that. Yeah, maybe. Maybe I can say next counts should be 0 at the start. Yeah, next counts. And this is way too much space. If for each divisor, the count increments. And then this should be next counts of the value is the next base. Okay, so this is the base times the multiplier modded. And then after all this, I say that counts is equal to next counts or something like that. I think this separates it out. Okay, didn't separate out anything. So you have a base that's 0, and you go through each value, you look at each divisor of the value, you increment it by how many times it occurred, how many times the later value occurs. Okay, and then for every value after that, you multiply how many times the base occurred times the multiplier. And then you set your next counts to 0. Okay, so I think I need to actually just print out what happens at each loop here. Okay, so start values is 1. Oh my lord. Next base of the divisor. Fuck. Okay, that's better. Next base of the divisor is there's 5, 2, 1, 1, 1. That's perfect. That's exactly what I was looking for. And then 5, 2, 1, 1, 1. So that should be 10. Oh, okay. And I think here counts becomes equals to next counts. I want to have a way to access the previous counts before I destroy it. Because I think 16 might be next iteration. Or maybe I just go one less loop. So for size, so let's say I have if n is equal to 1, just return the next value. And I say here it goes from 2 to n. That did not work. Not in the slightest. Alright, so going back to here. So it should have 5, 2, 1, 1. And then it shouldn't do another loop. 5, 4, 2, 3, 2. 5, 4, 2, 3, 2. That's in my next counts, which I made it into the counts. How to do this? How to store. What if I had next counts be equal to all ones here and current counts be all zeros? So next counts is here. And I'll make it so that the current count equals the next counts at the start of the loop. But then I would need to be able to modify it. They need to be separate arrays. They can't refer to the same array. Counts is originally ones. Why couldn't that work before? Counts is originally 1. And then I make it into Make it 52111. Counts as originally 1. My next, okay, what is going on here? What is going on? Okay, my original counts is all 1s. My next counts is, ooh, that's too much. My next count should be 1, 2, 2, 3, 2. I somehow skipped over an iteration. So if it's all 1s, so I went from 1, 1, 1, 1, 1 to 5, 4, 3, 2, 5, 4, 2, 3, 2. So it should have went from all 1s to 1, 2, 1, 2, 2, 3, 2. So 1, 1, 2, 3, 2. There should be 5 ways of doing the 1 start. And then 2 ways of doing the 2 start. So why am I multiplying anyways? So 5 ways of doing the 1 start. Multiplier not necessary. Is this thing not necessary? So what if you just said, what if the next base is equal to, what if the next base is equal to it? Counts equals to the next base. Oh boy. Okay, well, it worked, even if I didn't expect it to. Yeah, this seems a little too slow. Yeah. So I think in general it works, it's just too slow. Time limit exceeded. So I just need to optimize it somehow. Okay. So, how to optimize this shit? I don't need to have next counts at all. The next base is the same thing as what I was trying to calculate, I guess. So if you iterate through for each value that you have, for each value from 1 to n, n is this huge number, 2700. You have your counts, and then you increase the next time you see this thing. For each divisor of your value, increase the next time that you increase. For each divisor of your value. You should be able to almost say how many, you should know how many divisors there are of your thing. Right? So, or how many for each value, the amount of five, 5, 2, 1, 1, 1, and then 5, 4, 2, 3, 2, 5, 2, 1, 1, 1. For each value that you have. So how fast are they expecting this to be? I think this is n squared currently. Can you shortcut the calculation somehow without using iteration? So instead of iterating through all values of sizes of the array, generally the iterative process is generally the iterative process is necessary. Maybe. So if you have an array, the number of ways you can start off your array with something of size, the number of ways you can start off your array with the last value, your max value, should always be 1. And then the second to last value would be generally 1. So what was the multiplying thing that I did here? 5 times 1, 2 times 2. 5 times 1, 2 times 2, 1 times 2, 1 times 3, 3 times 1 times 2. So I didn't do any multiplication here at all. I took the counts, I took the I just do some straight multiplication somehow? 5 is the size of the array. 2 is 5 is the size of the array. 5 is the number of things that are divisible by 1. 2 is the number of things divisible by 2. 3 is the number of things divisible by 3. 4 is the number of things divisible by 4. Or 1 is the number of things divisible by 2. No, 5 is the number of things divisible by 1. 2 is the number of things divisible by 2. 1 is the number of things divisible by 3, 4, 5. And the whole thing is 10. No, the whole thing is now 16. And then here, 5, given that there are 16 ways. Of those 16 ways, there's 10 ways of having something that starts with 1. Number of ways. I wonder if this could be somehow done with dynamic programming. Somehow done with dynamic programming. So, what am I imagining here? 1, 2, 3, 4, 5. And this is some relation to n. So for each size of your array, so this is size, the number of ways you can start off with, you can end with these numbers is like this. Now what is the, so this is size 1, and if you have size 2, then what? 1 goes here, 1 goes here, 1 goes here, and 4 makes this become 1 goes there, another 1 goes there, and that becomes that, and 3 makes this become 1 goes there, 2 makes this become that. Doesn't quite, it's the same process that was what I'm doing here. For each number going to the divisors. Somehow there's the multipliers. Somehow there's the multipliers. So you have a previous iteration. If you multiply by the number divisors for that number, you get the next iteration. But then you don't get the number of actual, you get the number of ways of creating the next iteration, but not the actual count of the values. so you can't just multiply it all the time. Just you can use multiplication to figure out a shortcut. Use multiplication to figure out a shortcut for one loop. So that's n equals 2. And then n equals 3 would be the 1, 5 makes this 1, makes this 1, the 1, 4 makes this 1, 3 makes that, 2 makes the 2 2's, increase this to 3, increase this to 2 2's, one of the 2 makes this into 2, the other 2 makes this into 4, and the 5 1's makes this into 9. That's not right. So the 1 5 makes this into that and that. The 4 makes this into 1, 1 and 2. 3 makes this into 1 and 3. 2 2's. 2 things that start with 2 makes it into 2 2's can make it into each 2. What is going on here? The 1 5 makes into 2 separate things. The 2 2's makes into 4 possibly separate things. Where 2 of them could be 2's and 2 of them could be 1's. And 5 1's makes it into that. It's 10 3 6 10 3 1 1 1. You have one thing that starts with 5, one thing that starts with 4, one thing that starts with 3. 3 things that start with 2, 10 things that start with 1. Okay. 1, 1, 1, 2, 1, 3. 3 things here. They would make it into 3. At that point, this should be 2. At this point, it should be 1. And then this thing, there should be an extra 3 here, so it'd be 4, an extra 3 here, that'd be 6. And the 10 ones would be 16. So it'd be 23 there. 10, 3, 1, 1, 1. 16, 4, 1, 1. Interesting. Huh. I mean, the pattern here is going to repeat itself. It's going to be 1, 1, 1, and then the 4 becomes probably like a 5. And the 16 becomes, well, 1 plus 4 is 5, 5 plus 5 is 10, 16 plus 10 plus 6 is 16, so 16 plus 7 is 23. So the next one's going to be something. Next one will be like 23, 5, 1, 1, 1. So it'd be 8 plus 23, so 31. one for 5, 5. Yeah. Okay. Can you do that without doing this iteration? These iterations of it. So for every number, there's some set of divisors of that number that create the count of the next time. So 5 has exactly one divisor, which is 5, or one multiple. Yeah, for every number, there's some number of multiples of that number that create the count of it. 5 has only 5, 4 has only 4, 3 has only 3, 2 has 2 and 4, and 1 has 1 through 5. And that's the first pass. 5, 2, 1, 1, 1. And then the second pass, you would see how many 2's there were and how many 4's there were. So like 2 2's and 1 4, so that makes this 3. And how many of all the numbers there were, that makes this 10, 3 4's and 5's. And then for the next path, number 2's is the sum of the 2's and 4's, so that's 4. 1's for everything else. And 16 is the sum of everything. Yeah, there has to be a shortcut to this. I don't think this is too slow. This is probably fine. How to shortcut this calculation? So for every number, we're taking the sum of the counts of its multiples. Sum of the counts of its multiples. Or alternatively, for every prior number, adding the count of that prior number to the count of the next ones of its divisors. I guess this really slow one is actually 1. Like 1 is in every single loop. So you could possibly skip it and just say that the 1 is equal to the sum of the previous counts. So like for every start value that it's not 1. Where would I modify this? For every divisors and divisors. So I don't want divisor of 1. So for 2, so divisors, I'm not including 1. If I don't include 1, then it's not going to include itself. So maybe I just have divisors start with none. So I'm going to go ahead. This should probably be fine. So here, for every divisors, next base of this divisor is incremented by this value. Sure. And I'll say next base of 1 is equal to the sum of all the current counts. I think this still works. Okay. Probably still super slow though. This doesn't really change the fact that it's n squared. This shapes the time though. Oh. 2747 5606. Too big, too big. Turn the number of distinct ideal arrays of length n. I wonder if I can. So I wonder when this thing actually stops working out. What n is in the thousands. Oof. Oh my god. What is going on? Alright, let's succumb to a hint. Notice that the ideal array is non-decreasing. Okay. I think I noticed that a long time ago. Consider an alternative approach where an ideal array must be strictly increasing. Can use dp to solve it. Where an ideal array must be strictly increasing. Interesting. Consider an alternative problem where the array is strictly increasing. Can use dp to solve. Okay, so if the array was strictly increasing, so let's say n is 1, max is 5, so it'd just be obviously 1 for each, right? There's one way of doing each of those. If n is 2 and is strictly increasing, then you can't have 1, 1. You could have 1, 2. Here n is the start value, so there's, well, n is the start value. Well, no, these are the start values. Start value, and this is n is 1, n is 2. So the number of ways that you can start with 1 besides 2, well, let's do backwards. 5. There should be 0 ways of doing that. Like, you can't do 5 and then 5 again. 0 for 4, 0 for 3. There should be 2 ways of doing this. 2, 4, 2, 2. No, wait. Strictly increasing. So 1 way of doing this, 2, 4. And then 5 ways of doing this. 1, 1, no, 4 ways of doing this. 1, 4, 1, 2, 1, 3, 1, 4, 1, 5. Okay. And if n is 3, then still 0, 0, 0, 0. So 1, 1, 2, 3, 1. So 1, 2, 3, 1, 3, 1, 2, 3, 1, 2, 4, 1, 2, 5. This should be a smaller number of ways, I think. 1, 1, 2, 3. So 1, 2, and then because there's two ways of going from, no, there's one way of going from 2 to something bigger. So it'd be 1, 1, 2, 4, and that's it. 1, 2, 4. Huh. So the number of ways of doing 3 distinct values that are increasing would be just one way of size 3. Okay, sure. And there's 5 ways of size 2, 5 ways of size 1. Size 2 being 4 because there's 4 non-ones here, and 1 way here because there's 1 multiple 2 there. And there's 1 here because the number of ways of getting at the number of I mean, these 4 combined to this, these 1s combined to this 4, and this 4 became this 1, and then that 1 came from this 1 came from 1, 2, 4. Huh. I'm not sure. Where array must be strictly increasing. Can you use dynamic programming to solve it? I mean, based on this hint, somehow I can. Also, based on this hint, somehow I should be able to solve this other problem using it. Those two connections are beyond me right now. The combinatorics help to get an answer from the alternative problem to the actual problem. Okay, so they want me to solve this other problem and then use combinatorics to solve this one. Interesting. Okay, sure. So solving the strictly increasing case using DP. Okay, so how many ideal arrays are strictly increasing? So strictly increasing. So the divisors can't be itself. So for every number from 1 to max value, the number of the number of prior numbers should be its number of divisors not including itself. So it's number of divisors minus 1. So this is 0, 0, 0, 1. Is that right? The number of multiples not including itself. So 0, 0, 0, 1 from the 4, and then 4 from the 1 through 5. And then the next iteration maybe I'm thinking about this backwards. So you start with 1 or you start with 2. I'm thinking about this backwards. So if you start with 1, then there'd be 0 ways of making another one with 1. There'd be 1 way of making it with 2, 1 way of making it with 3, 1 way of making it 4, 1 way of making it 5. And the 2 would make this into like that. So 1, 2, 3, 4, 5. 1, 2, 1, 3, 1, 4, 2, 4, 2, 5. And then this would be so 2 goes to 4, so like 1, 2, 4. 3 goes to nothing, 4 goes to nothing, 5 goes to nothing. Is this any easier? Is this any simpler? At some point it becomes all zeros, I guess. And at that point you don't need to worry about anything after it. It goes to zeros faster. Okay, so at some point, like let's say n equals x, and you have all zeros. So then what? This isn't really dynamic programming though, this is still iteration the way that I'm calculating it. Like 1 causes every multiple of 1 to increase. So I'm not really using dynamic programming to solve this. Starting value strictly increasing. Strictly increasing. For every number dynamic programming would have it's generally, or maybe I'm thinking about it wrong, but you don't have multiple loops within the outer and inner loops. Like there's an outer loop that goes through, maybe the start value is an inner loop that goes through the size of the array. Then there'd be another loop that goes through like the divisors of the start value or the multiples of the start value. which would make it like n to the third or something like that. I guess you could have a dynamic program that has that speed. So you have n equals some length where it all zeroes out, and then what? So you'd have a okay. So how does I guess the question is, how does this compare to this? Using common torques. So if you had counts, 5, 10, 16, 23. 5, 10, 16, 23. You had a number of ways to wait, how is this even possible? Okay, here I guess n is the number of ways that you end with this value of this size. Okay. So there's one way of ending with 5 size 2, 1, 5, 1, 4, 2, 4, ending with 4, size 2. So the number of ways using common torques, number of ways that you end with 5 that are strictly increasing versus the number of ways that you end with 5 that could be repeating. So the number of ways that you end with 5 strictly increasing. So there's 2 ways that you end with 5 that are strictly, there's one way that you end with 5 that's strictly increasing. So 1 to 5. 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 2 to 4, 1, 2, 3, 4, 5. Those are the only strictly increasing pathways. And then there's the 1, 2, 4 pathway for 3. And because 4 doesn't go anywhere, there's no 4 pathway. Almost feels like a graph can be used here. One goes to 2, 1 goes to 3, 1 goes to 4, 1 goes to 5. One can always go to itself. Any node can go to itself. So if you start off with any node can start with itself. The node goes to its neighbors. I'm probably just redoing the same problem Ori did. I'm just solving it through this fucking loop. One goes to 2, one goes to 3. It must be strictly increasing how many ways to solve this. So if you have a graph where these are your nodes, and you're asking how many ways to solve is strictly increasing, it's basically asking how many paths are of a certain length. How many paths are of a certain length? Okay, so number of ideal ways where values are strictly increasing is equal to number of paths of array length where nodes are where graph has nodes connected graph has nodes where each node is equal to number of paths of array length in a directed graph that has nodes where nodes are connected to its multiple to nodes that are multiple to its value. Okay. Right. So can I solve that graph type problem? Probably. Find the number of paths of length n. I think I could probably solve that. Then how does that compare to the answer? So I know that there might be one path of length 3. Sure. What does that mean? There's one path of length 3. So length of path, there's one length is There's 5 ways. And length of 2, there's also 5 ways. And length of 3, there's 1 way. So then what? Actually, there's this be a length 2 path or length 3 path that has 2 nodes? I guess it doesn't really matter. This one off. No common twerks help to get answer from the alternative problem to the actual problems. How many ways do you have an ideal array where an ideal array must also be strictly increasing? So you have one way to have a strictly increasing size 3. There's 5 ways of a strictly increasing size 1. And there's 5 ways of strictly increasing size 2. And there's one way of a strictly increasing size 3. 1, 2, 3, 4, 5. That's size 1. Size 2. Size 3. And the answers to non-strictly increasing of size 1, 2, 3 was 5 for non-decreasing. Number of non-decreasing ideal arrays was 1, 2. This was 5. This was 10. This was 16, 23. And then 31. Yep. 5, 10, 16. You take the number of paths. If you have size 1, you're strictly increasing. And then you take all those strictly increasing ways and you multiply all those strictly increasing ways and what do you do with them? If you have a size 3 array, you have a size strictly increasing 1 times you need to know how many of those 5s end with a certain value. So it's always going to be a lesser number of paths each time. It's always going to be a lesser number of paths each time. So 5 total ways that you can end with 5, that you can have it strictly increasing from 1. 1, 2, 1, 3, 1, 4, 1, 5, 2, 4. Compared to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So the increasing stuff is 5, and there's 5 that are the same stuff repeated. The increasing stuff here is 1, instead of there being what? So you can always take the count of the number of ways that it repeats. You can always repeat. So the things that don't repeat are the things that increase. So it can always repeat. So 5 repeated is 5, plus the number of ways it can increase is 5. 10. 10, the number of ways it can repeat is 10. And then the number of ways that the number of ways it can increase. So there's 5 one-size array. Each of those can repeat. If they don't repeat, then there's 5 two-sized array that don't repeat. So it's 5 plus 5 is 10. And then for the size 3, there's 10. And if you repeat the last digit of those 10, then that would be 10 ways. And then if you don't repeat the last digit, then you'd be looking at the number of ways that you ended up with 2, went to 4. So there were 6 ways of doing that. So 6 ways of ending with 2, increasing it to 10 to 16. And then similarly so there's 16 ways here. You have a non-ideal array of size 4. And your repetition doesn't have to be the last digit at that point, or even at the 3-point. Repetition could have been the first or the second number. Oh boy, oh boy, oh boy. The length of the path, number of ways. Must be strictly increasing. And I do not know combinatorics well enough to make this connection. Okay. There has to be an approach here that works. There has to be a connection between the non-increasing versus, or non-decreasing versus strictly increasing. So size for the non-increasing versus non-decreasing versus increasing. Increasing is obviously smaller. Non-decreasing means that you can just have any number of repetitions of any of the things that you have in your sequence. One to two, 1 to 3, 1 to 4, 1 to 5. I mean, I guess that makes it a non-cyclical graph if you make that. So what if you started where you go from what if you started where you had nodes with certain values and counts each node traverses to a node that's connected to it, and does what exactly? Gives its count to that node's count. So 1 goes to 2, give it adds 1 to node's 2 count. 1 goes to 3, add 1 to node's 3 count. So eventually node 4 has a count of 2. And every other node has a count of 0. Or nodes 2, 3, and 5 will count 1. Could do that. Then what? But whatever the last number is, you could repeat it. So you could have a DP where you repeat it. So 1, 1, 1, 1, 1, 1, repeat. So whatever the last count is, just repeat it. and then for every one that, and then add onto it. Combinatorics. So all ones. The sum of that is 5. Then 2 to 5. All ones. We go 1, 2, 1, 3, 1, 4, 2, 4, 5. So there's 5 things of length 2. There's 5 things of length 2. 5 things of length 1 that gets repeated. 5 things of length 2. So that's 10. And then you can obviously repeat the last thing of all 10. So there's 10 things of length 3. And then for each one that is a non-leaf node, of which there is only 2 that's a non-leaf node. Notes. How many are at node 2? How many are at node 2? So we start with everything is at node 1. Everything's at count 1. 1 goes 2, 2, 3, 4, 5. And then, Interesting. So, of the 11 ways of doing this, if you ignore repetitions, there's 1, 2, let's see, 1, 1, 2. If you have a length 2 that's increasing, then all the other things are repeating. All the other things are repeating. And there are 3 spots that are repeating. And the number of ways that you can choose which 3 spots are repeating is it's not even the number of ways that you can choose which 3 spots are repeating. It's like the size of the array is 5, 2 of them are repeating. So there's 3 other numbers that 2 of them are not repeating, or 2 of them are the ones that are increasing. The other 3 are kind of whatever. They're repeating values of one of the 2 digits that are increasing. So there's 3 1s here, 3 2s here. So there's basically the 1 2 that's increasing either becomes like there's like 3 spots, right? Or 4 spots. So like the 1 2 can come here, the 1 2 can come here, the 1 2 can come here, the 1 2 can come here. So there's 4 different ways of kind of including the 1 2 that's increasing. Similarly, if it's a 1 3, there's 4 ways. If there's not increasing, then it doesn't really matter, there's just one way. But if there was not 2 numbers, but 3 numbers that were increasing, so like 1 2 4. Okay, let's consider this. So the 1 2 4, it could be surrounded by another 1, another 2, another 4. It doesn't really matter. So if it's a 4-length chain, it could be x1 2 4, 1x 2 4, 1 2x4, 1 2 4x. If it's not one of the start or one of the ends, then there's 2 possibilities. So if it's before, let me think about this. So it's either 1 2 1 1 2 4. The 1 1 2 4 would be identical to putting a 1 there. So it would be like 1 2 2 4, 1 2 4 4, and the last one repeating would just be the same. So there's three ways of doing. Kind of odd that this is just 3 ways. I feel like there should be more. But if it's strictly increasing size 3, I guess there's just 3 ways. I guess maybe if you repeat the number, it doesn't really matter. It doesn't really matter if you treat it as repeating the one before or repeating the one after, it's the same. So because there's 3 different numbers, what is the logic here? Okay, so let's try 5. There's a 5 chain where it uses 1 2 4 as it's repeating, as it's increasing values. This 1 1, so it could be 1 1 1 2 4. It could be 1 1 2 2 4. 1 2 2 4 4 1. What's the logic here? What's the fucking logic? So x1, x2, x4, x. Let's assume that you can only repeat the things that are after it. So is it like if it's a 5 length chain, then you do like 5 choose 3, 5 choose 3 as the number of spots that you're using to pick spots for increasing values. So let's say you pick A, B, C. If I choose 3, pick the spots for increasing values. And then how many ways can you pick what to repeat? Okay, so 1, 2, 4. How many ways can this be? Assume length 5. How many ways to make increasing part B 1, 2, 4? Okay, so this is 1, 2, 4, 4. 1, 2, 2, 4, 4. 1, 2, 2, 2, 4. There's 3 4s, 2 4s, 1 4. There could also be 2 4s using 1, 1, 2, 4, 4. 1, 1, 1, 2, 4. I think that's it. 1, 1, 1, 1, 2. 3 4s. 1. So there's 3 ways where there's only one of the 4. No, there's 3 ways there's only one of the digits. So 3 ways where there's only a single 2, 3 ways there's only a single 1, 3 ways there's only a single 4. I'm missing another way of doing a single 4. I think it should be 1, 1, 2, 2, 4. Okay, so 3 ways of having a single 1, 3 ways of having a single 2, 3 ways of having a single 4, and then 1 way of having 3 of one number, 3 4s, 3 2s, and 3 1s, and then that, yeah, so there's 6 ways. So how to think about that? 1, 2, 4, x, 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 x. So if you were to repeat a number, so it would be x followed by some repetitions of x, or 1 followed by some repetitions of 1, 2 followed by some repetition of 2s, 4 followed by some repetition of 4s. It would be 2 times 3 times 2 times 1 is 6. Then the other one where it's 1, 2, 4 and it's length 4 would be 1, 1, 2, 4, 1, 2, 2, 4, 1, 2, 4, 4. So there's 3 ways. I don't think there's 3 ways. So it's like n minus 2 factor. No. This is 3, which is the same thing as, no, 3 is the same thing as, I don't know, 6, 3 choose 2, 3 choose 1. This is 6, which is the same thing as 3 choose 2. That doesn't seem right. 4 choose 2. 4 times 3. 3 choose 1. 3 choose 1. 4 choose 2 is 4 times 3 divided by 2. So 4 choose 2 here. So of the, why is it 4 choose 2? Okay, let's keep on going one more here. 1, 2, 4 length. So let's say it's length 6. I assume this will be 5 choose 3. 15, 10. Man, really bad. So there should be 10 ways of doing this. So it'd be like 1, let's say there's only one 1. So like 1, 2, all 4s. And then say there's 2 2s, 3 2s, 4 2s. So that's 5 ways there. Okay, let's say there's 2 1s. And then there's 1 2, 2 2, 3 2. That's as much as it goes. And then there's, say, starts with 3 1s. 3 1s and then 2 2s. Can't go 3 1s, 3 2s. 4 1s. And that's how much it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So it is like the length minus 1, so it'd be like length minus 1 choose. This feels like it chooses the unique values minus 1. So 3 choose 1. 4 choose 2. So if it's the length, so I mean there's 3 things that you can repeat. So you choose one of them to repeat. And then here, why is it 4 choose 2? Why is it 4 choose 2? 1, 2, 4. You have 2 blank spots. I didn't think about it wrong. 1, 2, 4. There's one thing that you can choose to repeat. Here it's 2, 4. Is it something like 3 choose 1, 4 choose 1? That doesn't combine to 4 choose 2. 4 choose 2. Hmm. Four choose 2. 1, 2, 4. So you have 3 values, you're repeating one of them. There's 3 ways of doing that. Then if you have 1, 2, 4, and you're repeating 2 values, so it's either 4, 4, or 2. So is it like that? Then that's 6, choose 2. 4, choose 2. So choosing is you're picking which ones you want to repeat. Kinda. Three. So if you have 1 and you want to have some number of repetitions after 1, 2, some number of repetition after 2, 4, some number of repetition after that. How can you simplify this to be 4, choose 2? And you can simplify that to 4, choose 2. I mean, 1, 1, 2, 4. So if you think about it as dividers, where do you place your divider? So there's 2 dividers. There's 2 dividers. 'So at most, each number can appear 3 times. So 1, 2, 3, 4, 5, 6. So 6, choose 4. 6, choose 4. What is that? It's 15. Yeah, that's definitely not going to be 4, choose 2. So if you have 6, choose 4. 1, 2. What was that? That was 15. 4, choose 2. 1, 2, 3 fours. Okay, let's do this more. So let's say there's 1, 1, 1, 2, all fours, 2 twos, 3 twos, 2 ones, 1, 2, 2, 1, 2 twos, 3 ones. That's it. So 3 ones. 3 of them have 1 ones. 4 choose 2. So you can repeat the 1. Okay. 4 choose 2 is the same thing as 4 factorial, 2 factorial, divided by 2 factorial, 2 factorial. And this next one is 5 choose 3, which is 5 factorial over 2 factorial, 3 factorial. Five choose 3 for this one. Of the 5 ways that they're where's the 5 coming from? Where's the 3 coming from? Where's the combinations coming from? So 1, 2, 4 is your things that are increasing. So after the 1, your dividers are what? What are your dividers? Like, have 1 some number 1s, 2 some number 2s, 4 some number 4s. And then you're choosing 3. Choosing 3 to duplicate. We're choosing 3 spots to be duplicates. Why is there only 5 spots to... Why is there 5 spots? Where's the 5 coming from? Choosing 3 to duplicate, you're choosing 2 to duplicate, you're choosing 1 to duplicate. So if you have 1, 2, 4, and you want to fill it out with 2 duplicates. You want to fill it out with 2 duplicates. So if you're choosing amongst these 4, choosing amongst these 4 to duplicate? No, but then it just doesn't work. Because it's not like there's an increasing amount of spots between those numbers. Three fours. So if I remove the 1, 2, 4, if I remove from each of these a 1 and a 2 and a 4, 4, 4, 2, 4, 2, 2, 1, 4, 1, 2, 1, 1. What does this say? So if I remove the 1, 2, 4 here, 2, 4, 1, 2, 4. So there's all 1s, all 2s, all 4s. And the remaining stuff, there's somehow that equals if I choose 4. All these are unique as well. All these are unique, but there has to be some repetition now. 1, 1, 1, 2, 2, 2. 4 choose 2 somehow equivalent to this. This number of ways come up with these combinations. 4, 4, 2, 4, 2, 2, 1, 4, 1, 2, 1. So, so it could be starting with 1, starting with 2, or starting with 4. Starting with 1, starting with 2, starting with 4. I mean, this looks to be the same set of lists as this one. So the 4s add another 4 at the end. The 2s can add. So this can add another 4. This can add another 4. This can add another 4 or 2. 4, 2. This can add a 4. This can add a 4 or 2. And this can add a 1, 2, or 4. Interesting. Alright, well, math is the math, even if I can't figure out the actual rationale. That makes sense to me. So, if you know the number of ways that you can make an increasing, if you know the number of ways you can have an increasing array of size n, of size something smaller than n, let's say it's m, mini n, then the number of ways that you can fill out the remaining values is going to be, let's see, so let m equal ways to create ways to create increasing array of size k. And if that's the case, then the number of ways to create array by non-decreasing array of size n i.e. duplicating some values, repeating some values in the increasing array would be m times n. So this is 3. Size 3. So 6. So the n minus, so this length 5, this length 4, and you do size 3, so you have 1 left over. So it'd be 2 plus n minus m, choose n minus m. So it's always, I think that's right. So length 5, 5 is n, no, this should be k. 5 minus 3 is 2, then it'd be 4 choose 2, and then the next one would be 5 choose 3. As n increases and k stays the same. First one when n is 4 and k is 3, and then that's be 3 choose 1. Yeah. Okay, so let's go ahead and verify that this works for something simpler. So let's say size m is, or k is size 2. So like, let's say we're dealing with n is 4, and we're dealing with 1, 2. So it'd be 3 1s and a 2, and that's it. So k here's 2, and here's 4. There's 3 ways. So it'd be 4 plus 2 is 6, minus 3 is, minus no, 4 plus 2 is 6. Minus 2 is 2. That's not right. So this should be basically 3 choose 1. Should be 3 choose 1. But here n is 4, k is 2. So that'd be 4 minus 2 is 2. 2 plus 2 is 4. 4 choose 2. These ones were right. So here k was n is 4, k is 3, it ended up being 3 choose 1. And this one was n is 5, k is 3, and this being 4 choose 2. So as n increases, let's do this one more time here. N is 4, K is 2. N is 4, K is 3. Can't do K is 3. This is not possible. So N is 5, K is 2. Guess I should probably do N is 3, K is 2 as well. 1, 1, 2, 1, 2, 2. Let's 2 choose 1. This is 1, 1, 1, 1, 2, 1, 1, 1, 2, 2, 1, 1, 2, 2, 2, 1, 2, 2. Let's 4 choose 1. So the number that you choose should, oh, the number you choose seems like it depends on your K value and not your N value at all. So here was choosing, oh yeah, it changes based on your K value. This 3 choose, well no, 3 choose, this was 3 choose 1, 4 choose 2, 5 choose 3. That's 5 choose 3. That was 10. This one K did go up. This is 5 choose 3. Which is 5 factorial over 2 factorial, 3 factorial. So here the K did go up. Or the number that you choose did go up. Here the number that you choose does not go up. So like this could all be all 5 ones and a 2, 4 ones and 2 2s, 3 ones, 3 2s. Yeah, so this becomes 5 choose 1. Somehow this one does not. 5 choose 3. My lord. You 1, 2, 4. Maybe it's not. Maybe it's not. So if you have your increasing portion of your array, what if you thought about it as there's a certain number of differences that are increasing and a certain number of differences that are the same, and you're choosing which of those differences are increasing. So yeah. So if there's n numbers, there's 5 spots where you can have a change, and you're picking one spot where it's increasing. And if you have 6 numbers, there's 5 spots that you're... how does this make sense? Start here, 1, 2, 4. Size 4. So you have 4 digits, and then there's three spots that you're dealing with that could be increasing. No, there's 3 spots that you're dealing with, and one of those is not increasing. So of those 3, you're choosing one to be not increasing. And here, if it's 5 length, then there's 4 spots that are between, and you're choosing 2 of those 4 spots to be the ones that you're either increasing or not increasing it. And here, 6, there's 5 spots that are between the 6 numbers, and you're choosing 3 of those spots to be increasing. Or you can also think of it as choosing 2 of those spots to be increasing. So you could do, it could be 5 choose 2 for the non-increasing spots, non-increasing deltas. Okay. Okay, so let's say here for length n sized array, if unique values are if there are k unique values, there will be k minus 1 gaps where values increase out of n minus 1 gaps. So number of ways to form non-decreasing array is n minus 1 choose k minus 1. Yeah, okay. So 5 choose 1, 4 choose 1, 3 choose 1. So here n is 5, k is 2, k is 3, so it'd be 4 choose 2. Okay. Alright, so I think that I'll solve that part of the combinations deal. Okay, so if I can count the number of ways to form something of length n or m, let n choose great theorems. Let's see. I gotta just do this. Length n, there are k unique values. So here, okay, so here it's going to be three ways to form something that has length 1. So if we do the test case here, so let's say n is 3, max value is, or n is 5, max is 3. So unique ways to form increasing of size. There's 3 ways. And so the total is going to be 1 minus 1 would be 0, choose 0, choose 0, so that's like 1. So there's 3 ways of doing that. So that means there's 3 ways of getting like all 1s, all 2s. All 1s, 2s, and then let's say size 2, there's 2 ways of doing this. 2, 1, 2, and 1, 3. So the total number of ways of filling in the gaps there would be 2 times n choose 1. So n minus 1. Is n minus 1 choose k minus 1? For length n sized array, there's k unique values. There's k minus, it's n minus 1. So there's 4 gaps, and you're choosing 1 gap to be, so that'd be 8. And that is 3 plus 8 is 10, is 11. Okay. Okay, so let's go to the n is 2, max out, n is, let's say n is 3, max value is 5. So the answer to this should be n is 3, max value is 5. The answer to this should be 10. Okay. So 10, so ways to form increasing of size 1. There's 5 ways to do that. Size 2. There's another 5 ways to do that. Size 3. There's 1 way to do that. And then for size 1, be 5 times how many gaps there are. So there's n is 3, so there's 2 gaps. Choose total is n minus 1. So 2 choose 0, which is 5 times 1, which is 5. And then 5 times, if you have size 2, then there are still 2 gaps, and you're choosing 0 still? No, you're choosing 1, which is it's not right, it's 10. So 1 size 2. Oh wait, yeah, this should end up being 16, right? N is 3. Should end up being 10, 3, 1, 1, 1, yeah, 16. Okay. And then size 3 would be 1 times 2 choose 2, which is 2 choose 2 is 1. So 5 plus 10 plus 1. Okay. Alright. So for each, so I need to calculate the number of ways of getting, alright, I'm just going to delete everything here. Delete most things here. Can I do this using a graph? I prefer that over DP. So number of ways of getting a certain length on your graph. So how would you do that? So kind of have the graph based on your divisors here. This is kind of like your graph. Okay, I just need to treat this as my graph. So for each number, the divisors of it. Don't want to include itself though. So I don't think I want to include self. So divisors would not include the number itself. Not including self or 1. Wait. I'm thinking of in reverse fashion right now. How do I get the number of multiples? Does it matter? 5 goes to 1. 5 goes... divisors of a number versus the multiples of a number. So if I use the get the divisors of the number, start from any number, the chain of things that go from that number. Yeah, I think this is probably fine. I'm just confusing myself right now. Okay. So if I have each number and I have its divisors as the graph. So the nodes are like 5 to 1, 4 to 2, 3 to 1. No, doesn't make sense. I know everything goes to 1, so I can maybe ignore that. So the graph ends with something that isn't 1. So for each number, I'll go to, I think I can maybe use a double-ended cube for this. Get divisors for each number in the range of 1. Yeah, I'm tempted just to delete everything here. have the modulo, my answer, my graph, which goes from number to divisors, not including itself. Yeah. Maybe it should include one. No, I'll include this off of it. So I'm going to have a deck for double-ended queue, and it'll have all the numbers in the list. That is the range of numbers. I think I can use range. Range of max value 1 to max value plus 1. And then let's say while there's a deck, say the size of the deck is something that I need to track right now. And so the current size is the current number of values, or current number of paths that are increasing of this size. Size matches count of paths of this level, which is length. So if I'm traversing the graph, the level that I'm dealing with is the same thing as the length of the array of unique values. So for every how should I do this? So I want to traverse every node, and then for every node go to its divisor nodes. So 5 goes to 1, 4 goes to 2, 2 goes to 1. What happens if I have multiple ways of getting to divisor node? Like 6 goes to 2, 6, 4 goes to 2. Does that count separately? So for each number of ways, can form something of increasing size. I think it counts separately for determination of number of paths, but for determination of number of ways on the next iteration, it's not. Like 6 goes to 2 or 4 goes to 2. It still counts as a 2 on the next iteration. If that's the case, number of ways. An ideal array must be strictly crisp. So we can go 1 to 2 to 4, or 1 to 4, 1 to 4, 1 to 2 to 4, 1 to 4. Number of paths to get to a certain value. So we can go 1 to 2, 1. Size matches count paths. Okay, maybe you have something like is the counts. Counts is the, let's say, default dictionary. So for each value in my deck, so for I in range of size value deck.pop left. I want to add all the divisors of this value to the next iteration. So deck.append. So for each divisor in divisors of this value minus 1, deck.append this divisor. But then it's going to be appending duplicates. Okay. Next level is empty array, or empty set maybe. So I'll do next level dot append this divisor, and I need to increment the counts. The counts just, I don't think I need to increment the counts. I don't even need to keep track of the counts. I just need to keep track of which things are on the next level. I guess I should probably increment the number of things. Maybe I don't keep track of size here. So 1, 2, 3, 4, 5. There's 5 things of length 1. And then when it iterates through it, it's going to find that there should be 5 things of length 2. And those 5 things are the 2, 3, 4, and 5. When it iterates through that, it should find that there's 1 thing of length 3, and that 1 thing is 4. No, but it's going backwards. So it's going to go through and say that if it ends with a 5, so ends with 5, 4, 3, 2, 1. So find that it'll add 1 a bunch of times, and there'll be 4 of these. And I'll add 2 once. And then the next iteration, 1 will become 0, and 2 will become 1. Yeah. Okay. So you're adding on, so you track the number, the count of things that you add, the number of things you add to the set is going to be, the number of things you add to the set should be the number of values at the next level. So I don't think there should be a deck really, there should probably be a set. Let me say count 0 here. Each time you go through a divisor and you do next level, add that divisor, you add the count, add that to a count. Yeah, this should probably be shouldn't be a deck. Okay. Anyways, after all this, you'll eventually want to make the deck is equal to the deck of the next level, and you'll want to increment the answer by the count here. Okay, I'll say here level starts with 1 or 0. I think level starts with 1. Where level is the size of your array. So the number of one size array would be that, and then it would be math, the count times math times combination of the level minus 1, choosing, no, it's not level minus 1, it's n minus 1. So that's n minus 1 choosing level minus 1. Mod and then this increments the level. Turn the answer. Divisors. Did I not? Oh, I called this the graph. Math.combine. Combinations. NK. Expected 2 arguments, got 3. Python, math, combination, mod. Thought there was a way to use combinations with modulo. Pretty sure I did this like less than a week ago. Python math mod with combinations. Huh, is it literally just using mod? I thought you could use mod within the called combinations. What is going on? My memory is just bad. What is I think it was like using counting good numbers. Does it count as powerful numbers? Was it not even a hard problem? Counting good triplets. There was something that used mod. Maximum value, minimum operations, count number. There was something that used mod recently. It was almost certainly combinations. Python combinations with mod large values. Oh, it was POW, wasn't it? Yeah, it was POW, not mod. POW mod. Okay, okay. So maybe combinations. I don't really. Count times that mod. Okay, I think maybe. Wrong answers. Okay. So let's go ahead and print level in the deck. Okay, so length is. Did I already do the? Yeah, I already did trivial case. So deck is 1, 1, 2, 3, 4, 5. Okay, the size was 5. Then the count should be, let's see, print and level and and let's say what the count is for this level. So okay, I think I need to actually include 1 in the divisors. Yeah. Let's actually go to 1. Oh, okay. Yeah, I don't need to do this for output level. That should be. It should be going at this many levels. Uh-oh. 1 can't include itself. I see. 1 can't include itself, but everything else can. So I think the graph of 1 should pop. Okay. So this is correct. So 1, the first level should be 1, 2, 3, 4, 5. The second level should just be 1 and 2. First level is 1, 2, 3, 4, 5. The count there is 5. Perfect. And the next level is 2. The count there is 1. Yeah, so 2 goes to 1. So 5 is kind of the number of ways to form something of length 2, and 1 is something of length 3. And there's 0 ways of forming something of length 4. Okay. So my output is 6. I think my answer should start not with 0, but with the actual number of values. That will only add 5 though. No, this is wrong. So the count was 5. So there's 5 ways of forming something of length 1. Right, there's 5 ways of forming something of length 1. And then the next one, the count was 2. Fuck me. Okay. So there's 5 ways of forming something of length 1. And 1 way of forming something of length 2. Actually, that should be wrong. So it should be 1, 2, 4, or 1, or 2, 4. So 2, 1, 2, or 2, 4. So 4 should go to 2. And level 1 count is 5. And level 1 count is 5. So that should be this. And the 2 values are 1 and 2. And then n level 2 count is 1. Yeah, okay. Should work in some ways. So the answer. So let's say wait, level ways is equal to this stuff. The level ways. Okay, so there's 5 ways of doing something with length 1. It should be 2. What's going on here? So should I be adding on to this? There's 5 ways of doing something of length 1. And then you multiply that by 1 for each of those ways. There's one way of making it actually 2 length, like duplicating it. So that'd be 5 times 1, which is 5. And in the next level, there should be 5 ways. On the next level, there should be 5 ways too. Okay. So actually it should be like something like the size of the current level. The size of the current level is actually the thing that you use. So the size of the current level is what you actually use. The size of the current level is what you actually use. And why would you need to keep track of count at all? Don't think that you need to keep track of count. What if you just did not have count? Wrong. So what do you need the count for? So this should be 5 here, 5 here, 5 here, 5 here, 5 here. So 5 should be the total number of ways. But what I actually did was this 5 right here. I added 4 plus 1, got 5 there. Maybe I should be doing like offset by 1. Maybe answer should in fact start with level. So the answer is going to include, no, it's not right. No, the answer, yeah, answer starts with max value. So the answer includes everything that is size 1. And that's all the values are duplicated. So then here I do keep track of count, and count does make this. Still gonna be off. My output's 5. Actually, answer is 10. So the level, the number of waves, oh, oops, count incremented. Okay. So there's 5 ways of doing something that is of length 2. And then because there's 5 ways of doing something of length 2, should there be 5 ways? Yeah, I think so. It should be 1, 2, 1, 3, 1, 4, 1, 5, and 2, 4. So if there's 5 ways of doing that, then but here n is 2, so that should be it. Oh, I see. I need to stop this. This is including everything at level. While deck and level is while deck and level is less than n. Okay, so this is correct. So let's put 1, 2. Let's do another test case here. N is 3. X value is 5. Okay, so correct answer is 16. Got 12. So there's 2 ways of doing something of length 2. 1, 2, and 1, 2 ways of let's see. So level 1 is something of length 2, level 2 is something of length 3. So 1, 2, 4. Why is there 2 ways? There should only be 1 way. 1, 2, 4. Ends with 1. And 1 has where's divisor of 1? Level ways there should be 4. Level ways there should be 1. Level ways 5 and level ways 1. Why is it 2? Okay, we'll go ahead and print out. Print the count here and for every I in range size. Yeah, sure. Value and divisor. It only printed out. Only print out one thing though. Oh, print out one thing which is correct and then somehow multiplied by 2. So if it's 1, 2, 4, and it's length 3, would be the count, increasing count, which is currently 0. So it becomes 1. The value is 2, the value is 1. So that's right. So this means that you have something that is like 1, 2, 4. So there's one way of doing that. And then the count is 1. One way of doing that. And this is length 3. So it'd be 2, choose 2, no? N minus 1 is 2. Level minus 1 is, level minus 1 is actually 1. So choose 1. Right now, maybe it should be level. Maybe I did this wrong. Sweet Jesus. Jesus. Wrong answer. Okay. Huh. The other cases were right. This one's wrong. 5, 9, 93. Okay, so let's go ahead and just try some smaller test cases. 1, 9, 2, 9, 3, 9. N can have value from 2 to 2000. What? N to have values from 2 to 10,000 only. Invalid test case. Did I put a space bar somehow? Oh, this thing needs to be 2. Okay, so it worked on 1 and 2, but not 3. Okay, so what's going on here? It's probably something with to do with like 9 and maybe 3. Like, does this work for something that is just an odd or a square number? Like, let's say 216, 316. Yeah, 216 works, 316 doesn't work, 29 works, 39 doesn't work. It's probably something with square numbers. Okay, so what makes sense as to how I screwed up the square numbers? Let's go and just print out the graph. Okay. 1, divisible, divisor of 1 is 1, 2 is 1, no, divisor 1, 2, 1 is divisor of 1, 2 is divisor of 1, or maybe, no, nothing is divisor of 1, 1 is divisor of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That looks right to me. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Huh. How odd. I wonder if something smaller like 2, 4, and 3, 4. Do those work? 2, 4, 3, 4 works. Maybe it's not square numbers. Maybe it's just the 3 case. 3 with any random shit. So 3, 9, say 3, 3, 12. 3, 12 is wrong. Okay. 4 works. Interesting. Okay, these outputs are too large for me to identify all the test cases or all the expected values. Right, so where would this not work? What is the smallest 3 value that fails? So 3, 4 works, 3, 9 doesn't. I'm just going to go through. Bigger values 3, 3, 5, 6, 7, 8. 6, 3, 7, 2, 8. Okay, so it's slowly getting worse. So it's 3, 6. So minus 3, max is 6. You should have 1. For the unique ones, it'd be 6 of them. The mini size is 1, there should be 6. Mini size is 2, there should be 1, 2, 1, 2, 1, 3, 1, 4, 1. How should I write this? 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 4, 2, 6, 3, 6. That's it. So there should be 5, 6, 7, 8. And if the mini size is 3, then there should be 1, 2, 6, or 1, 2, 4, 1, 2, 6, 1, 3, 6. And I think that's it. Okay. So let's go and print this out. So level ways, there's 16. Holy shit. Where does it start with 16? Wait. Okay. 16. No, I'm reading the wrong thing. Level ways. Level count. Count. Alright, so the first one is 8, which... Okay, the sixth one is already included. So the first one's 8, which is right. But 8 should be adding... 8 should be adding 16, because for each of those 8 ways you can be duplicating either the first or the second number. So it's 16. Okay, sure. And the second, that's not right. It should be 3 ways here. Because it should be, is it 3 or is it 2? I guess you can either go 1, 2, 4, or 1. Let's go level count. Okay, so the first level is 1 through 6. The second level is 1 through 3. And for 1 through 3, it can go 2, 1, or 1, or 3, 1, or 1, 2, 1, 3. I counted 3, it counted 2. I count 3, it counts 2. Yeah, so I do need to worry about how many times I can get to that number. Oh, shucks. So 1, 2, 4. So if I had 1, 4 goes to 2, 6 goes to 2, 6 goes to 3. I'd have 2 2s and 1 3. Two 2s and 1 3. So this should be 6 times 1. And this should be 8 times 2. 8 times 2 is 16. 6 times 1 is 6. 6 plus 16 is 22. And this is 3. And then 3 times 1 is 3. So that's 25. So what does that mean? I need to keep track of the count. Keep track of the count of the number of ways to get to a certain value at each level. Keep track of the number of ways to get to a certain count, to get to a certain value. And then what? Because if there is so 1 through 6, for every way that goes to 1, there's going to be 6 ways that does, or 5 ways that does that. 5 ways that it decreases down to 1. And those 5 ways counts as nothing when it decreases down to 0. Then there's going to be 2 ways that counts that goes down to 2, and 1 way that goes down to 3. 4 to 2, 6 to 2, 3 to 6 to 3. Then each of those ways counts as 1 when the 2, 3 goes to 1. Alright, so now the deck. Okay, so while every I in range size, so deck has some number of values. I guess maybe I need a frequency. Could use a frequency. I could just use. I just could use a. I don't even need a frequency. Maybe I just use. I probably should use a frequency. Frequency equals I guess maybe I should use next frequency, or frequency of is 0 times the frequency is default dictionary. Okay, so whenever I see a divisor, add it to the next level, and then I say frequency of this divisor, and it's incremented by 1. And then what? And the count should be incremented by the previous frequency of this number. Or the count should be incremented by what? So for instance, the frequency of 6 should be frequency of 2 should be 2. So the count should increment by the previous frequency of this number. The should be incremented by, so 2 goes to 2, 2 goes to 1, and count should increment by the frequency of this number. So I think pass frequency should be originally 1 times everything. Okay. Now it should be increment by the fast frequency of this value. And then at the very end I say that the fast frequency is the current frequency. Oh my god. Here. Only 2 out of 47. Those are huge numbers. Okay, let's see the test cases. So those worked. I wonder if I'm not using modulo correctly. Back is crashing or giving an incorrect rather than timing out is in some ways sad. So I mean it worked. So let's say n is 36, 37. Okay, let's try n is 10. Okay, let's go further. Let's try n is 2. N is 2 works. Let's try n is 4. Okay, between 2 and 4 did not work. So let's try n is 3. Okay, so 3 worked, but 4 didn't work. Okay, so what's going on here? There's a huge jump. 2032 versus 1905. So you have some level. times. Wonder if it's just a matter of the ways that I am actually doing this modular arithmetic. I don't think it should matter. Yeah, this should matter. 243. Is there something special about 71? Okay, so let's say count level 3 is fine-ish. So let's say it's level 3, something smaller like 50. Level 3, 50 is fine. Okay, let me try to find the smallest test case that I can figure out something is wrong with it. Level 4, say 15. Okay, level 4, 15 is wrong. Okay. Level 4, let's say 8. Well, 8 is correct. Alright, for 9, 10, 11. Oh, not 8 or 11, that's too big. 9, 10, and 11 is fine. 12, 13, 14. Alright, level 4, 12. So it should be 133. I got 132. Okay. Alright, so that's 12. So mini 1, that should be just 12. And then minis 2, there should be 1, 2 to 111, or 112, that's 11 of them. 2, 4, 2, 6, 2, 8, 2, 10, 2, 12, 3, 6, 3, 9, 3, 12, 4, 6, 4, 8, 4, 12, 5, 10, 6, 12. So that should be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So it should be 23. Alright, so length 3. So it should be 1, 2, 4, 1, 2, 6, 1, 2, 8, 1, 2, 10, 1, 2, 12, 1, 3, 6, 1, 3, 9, 1, 3, 12, 1, 4, 8, 1, 4, 12, 1, 5, 10, 1, 1, 6, 12. So everything with a 1 before it, pretty much. Well, I said 6. 18. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Instead 16. I got 12, maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how's there 16? Oh, it could be, could start 2, 2, 4, 8, 2, 6, 12, 3, 6, 12. And what else? 2, 4, 8, 2, 6, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 2, 4, 12. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 seems right. And then 16, if you have 3 of them, then there should be, so initially there should be 12 plus 23 times 2 plus 12, 23 times 3 choose 1, 3 choose 1. No, so it's 12 times 3 choose k minus 1, so 3 choose 0. 23 times 4 choose, or 3 choose 1, plus 16 times 3 choose 2, plus 3 times 3 choose 3. Or 3 choose 3, choose 0, choose 1, choose 2, choose 3, yeah. Okay, so 12 plus 3 choose 3 is 3, so it's 69. 3 choose 2 should be 6, should be 3 as well, so that'd be 32, 48. And then another 3. 12 plus 69 plus 48 plus 3. 132. So my formula is just wrong somehow. I'm miscounting something. So this one would be 1. There should only be 3 ways of forming something of 4 length. So 1, 2, 4, 8. 1, 2, 4, 12, 1, 3. 2, 4, 8. 1, 2, 6, 12. Okay, so all values are correct. Okay, so my combinations is just wrong. So 1, 2, unless there's a missing 2, 4, 2, 4, 8. No, that doesn't work. Well, 69, 48, 3. There's a missing one. So the number of ways you can form something. So, I mean, it's either me missing out on, somehow it's just not counting it correctly. Seems like the smallest value I can detect it with. 23 ways of doing 2. 2 to 112 is 11. 2, 4, 6, 4, 6, 8, 10, 12, that's 5. 3, 6, 9, 12 is 3. 2 is 1. So 1, 2, 4, 7. Plus 5 is 12. Plus 11 is 23. I mean, this probably has to be correct because you're still multiplying it by 2. So it shouldn't be multiplying by 3. You have one thing, then it's just all that one thing. All 4 things are that one thing. And you have 2 things, then there's 3 places that you can increase, and you're choosing one of those places. So 12. Well, wait, it's 12. Yeah, there's 3 places. There's 23 things. 3 places, you're choosing one of those places to increase. So it's 23 times 2, 6. Wait, I'm doing this wrong. 23. There's 3 places. You're choosing one of them. So there's 3 ways of doing that. 69 total. And there's 16 ways. You have 3 numbers that you're increasing. There's 16 ways of hitting those 3 numbers. And you're choosing out of the 3 spots where it could be increasing or decreasing, 2 of those spots to be increasing. And then lastly, there's 3 ways of getting 4 numbers that are increasing. And then that's pretty much it. What am I missing? 1, 2, 4, 8. Feels like it should be missing like a 4, 1 or something. 1, 2, 4, 8. 1, 2, 6, 12. 1, 2, 1, 3, 6, 12. Can't be 1, 4, 1, 4, 8. I already have them put here. Can't be starting with 4. Can't be starting with 2. 2, 4. 2, 6. 2, 6, 12. 2, 4, 12. 2, 4, 8. 2, 4, 8. divisible by the last number in your previous number. Level 3 count is 3. So so fucking close. 136, 137, 152, 153. Just wish I could come up with a simpler test case to demonstrate where this goes just wrong. Or somehow figure out what the actual answers are. I wonder if ChatGPT could. How many ways to form 3 increasing numbers from 1 to 12? No, that's not even it. 3 increasing numbers where each successive number is a multiple of the prior number. Hmm. 16. What? 16. What? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So, how many ways form 2 increasing numbers from 1 to 12, which should be 23? Okay. And then to form 4 increasing numbers. Should be 3. Wait, there's 4. 1, 2, 4, 8, 1, 2, 4, 12, 1, 2, ooh, my god. 1, 2, 6, 12, 1, 3, 6, 12. Okay. So my last count was wrong. Alright. Okay. So I guess what I need to know also is at the end of it, what the frequency of the next values are. Okay, so okay. What am I expecting to see here? So it should be expecting to see something besides this, I think. 2 is 1. This should be something like, no, I guess that's right, 2 is 1. Okay, sure. So here it should be 3 2's rather than 2 2's, and 1 3 is correct. Interesting. So, okay, so should be, yeah, pretty sure there should be 3 2's and 1 3. So the 3 2's should come from the 6 and the 4. Because the 6 should move to, the 6 should move one of the 2's, and the 4 should move the other 2's. Okay, so the frequency of the divisor plus equals plus equals 1. This should be plus equals the frequency of should be the past frequency of this value now. Frequency of this divisor. Oh, the streak is alive. Oh, God. Alright, do I care to try to optimize this? The answer is that is... Do I care to get food? No, no. Do I care not to get food? Alright, I think I'm gonna be... I don't know if I would optimize this. 61%, so bad. So what did I not really need? I don't know if I need a deck. So for every number, find what's divisible by, and then I think I just need a set here and go through the values of this set. I don't think I ever use size. So now I use size when iterating through here. Okay, I might just break this thing in half, but so say these are, the deck is really the n values, and this is going to be a set of all the values in the range from 1 to max value. And maybe I can just try rewriting some of this code. Level equals 1. Pass frequency for everything is going to be 1 times the max value plus 1. And then while the level is less than n, I think you always I don't think you ever, while the level is less than n, no, I guess you do, and there are some n values in play. So you have count, let's start count with 0, sure. Sure, you say frequency is some default dictionary. I don't think you need to go through size. I think you say for every value in your set. So in your next level, okay, I think you have a set for your next level. I guess maybe you can call this your next values. Next ends. And then for every value in your set, in the n values, for every divisor in the graph of that value, and then you can have the next level add the divisor, the frequency of that divisor is going to be past frequency of this value, and then the count for this level is going to be past frequency. Wonder if you can just sum up all the values in past frequency somehow. Like the count is just going to add up all this past frequencies eventually, right? Maybe not, because it doesn't. No, it doesn't. Okay, it's different because it needs to have a divisor in order for it to have another incrementing of the count. Okay. I wonder if I should be doing mod there. Past frequency. The level weights. Yeah, maybe I should be doing mod there. Frequency divisor. And then ways is going to be equal to count times math combinations of n-1 in this level. And it's been connected by the ways. Answer. Yeah. And then I make my n values be the next ends. Wait, did I do next ends? Next level is next ends, right? say level increased, and pass frequency becomes frequency. Pass frequency becomes the current frequency is. And then turn answer. Okay. Alright, I don't think I actually really. I mean, I got rid of the deck. Yeah. Okay, it is what it is. I'm going to optimize this further.